All right, we're going to do two problems on precipitation stoichiometry. And we have a reaction on the right side here that is showing a reddish precipitate or a solid forming when a solution is added to another solution. So the question is, what mass of Na2CrO4 or sodium chromate is needed to precipitate all the Ag plus ions from a 100 milliliter solution of 0.8 molar AgNO3? Sounds very complicated. So we need to break this down. Let's talk about what the equation is. So what I'm basically doing is I'm taking the sodium chromate and I'm reacting it with the silver nitrate. Because of that, that looks like a double replacement reaction. So I'm going to have now my sodium with my nitrate, and I'm going to have my silver with my chromate. Okay. Now we need to balance this. So there's a 2 on the silver, and because of that, the 2 with the nitrate. If you look at your solubility rules, you should notice that I have sodium and I have nitrate, so that's got to be AQ, so that must be my solid. Okay, that's my solid. I can do a down arrow, or I can say that that is just a solid in my states of matter. So I like to organize my information. I have 100 mils. Right now it seems confusing. I have 100 mils of my silver. This is where my silver is located, and I'm saying it's 0.8 molar. We'll talk about what that means in a moment. And what's saying is, what is the mass of my sodium chromate? So if you think about this in terms of a net ionic equation, basically net ionic, I'll do it on the top, it would be the silver ion and the chromate ion producing the silver chromate. Right? And there'd be 2 of these. So what it's asking is, how much of this, or how much of my sodium chromate do I need to cause all of this, the silver, to become my solid? So it's basically stoichiometry. I'm asking, what is the perfect amount of my sodium chromate that I need to consume all of the silver ions that are present? So one quick thing to know, when I say this, when I say molar, your mind needs to go to the fact that it's actually that many moles per liter. Okay? And that's a big deal. So I'm going to do this all in one step. I'm going to go from my silver nitrate to my sodium chromate. So if you think about this, and there's a couple ways you could do this, but you need to get into moles eventually, one way or the other. So there's one way. I'm going to do this on the side. You could say that I have 0.8 molar equals 0.8 moles over 1 liter, right? Let's just get rid of that. That's what that means. And then what I could do is basically say, well, I have 0.1 liter to react. So liters would cancel. Okay? Or you could do it in a different way. So that idea, sorry if that's confusing, but basically I have 0.1 liters and I have 0.8 moles of my silver nitrate over 1 liter. Mindful that that right there is my molarity. Okay? Then, now I'm in moles. So how do I get from moles to grams? Well, right here, grams, moles, grams. So I'm already in moles. Now I need to get to the other mole and then to the grams. So now it's all about units, you guys. So mole ratio of what I'm in, 2 moles of what I want. And I have 2 moles of silver nitrate for every 1 mole of sodium chromate. Then I have 1 mole of sodium chromate to what? The grams of sodium chromate. And if I do that, 2 times 23 plus 51.9, 52-ish, plus 16 times 4, I get 162. So what I get is I would need 6.48 grams of Na2CrO4 that is needed. Okay, so if I have that much, it will cause all of the Ag plus in that solution to become my solid. So that's how you do the first problem.